Here is a short review of inequalities. That is less than or equal to, greater than, or greater than or equal to. This corresponds to variables and patterns investigation 4. This inequality says x is greater than 5. So that means that x could be 5.1, 5.2, 5.3, 5.31, 5.32, 6, 7, 8, 200. It would look like this on the number line. The 5 would be empty, the circle, because it can't be 5, but it can be greater than 5. So it could be anything along here, 6, and so on. The second example is x is greater than or equal to 5. That means x could be 5 or 5.1, 5.2, 5.3, any of these numbers all the way through up to infinity. So this one looks a little different. Now the dot is colored in where it was not colored in before, because it could be equal to 5, but it's also still greater than 5. So greater than or equal to is colored in. Remember that solving an inequality, we do very similar to how we solve equations. We want to get the variable by itself, so we say, how can we get rid of plus 2? Well, the opposite of adding 2 is subtracting 2. Anything we do to one side, we do to the other. And then we bring everything down and we find that x is greater than 5. So this would actually be the same as this situation right here. Here are some examples. Let's say we have x plus 1 is greater than 4. We're going to subtract 1 from both sides to get the x by itself. And now we know x is greater than 3. So if x is greater than 3, 3 is not colored in, and it's greater than 3, so it would go this way, just like that. Here's another example. This one says x plus 3 is less than or equal to negative 2. Again, let's get x by itself, so we will subtract 3 from both sides, and that will give us x is less than or equal to negative 5. So here's our negative 5, and this one is going to be colored in. So let me do this first, and then we'll pop back here and color it in real quickly. So this one's colored in because it's less than or equal to negative 5. So it could be negative 5, but it could also be less than or equal to negative 5. And our last example here says 0 is less than or equal to x plus 3. Again, let's try to get the x on one side and the numbers on the other. So we're going to subtract 3 from both sides. Now we have negative 3 is less than or equal to x. You can rewrite this inequality as x is greater than or equal to negative 3. Do you see how I just flipped that? And if we did that, x is greater than or equal to negative 3 would go this way. And because it's greater than or equal to, we're going to have to color this dot in again, so it'll look just like that. Finally, sometimes you will have word problems that have inequalities. For example, if someone's going to Six Flags, the sign may say he must be at least 50 inches tall to ride the crazy coaster. That would be h, his height, is greater than or equal to 50. That means he could be 50 or 51 or 52 or 52.5 inches tall, but he can't be 49 inches tall or 49.5 inches tall. Here's another example. She can spend a maximum of $4 on the gift. That means the money that she's going to spend is less than or equal to 4. So she could spend a maximum of 4, but she could spend $3.95 or $3.90 or even $3.89 or $2, or if she's a real cheapskate, maybe 25 cents. Here are some other signal words to kind of watch for. Greater than and more than, we know that one. Here's greater than or equal to, which is our height example. So he's at least 50 inches tall, or he's a minimum of 50 inches tall. And then here's less than or smaller than. And less than or equal to, this is our maximum example. She's going to spend a maximum of $4, not more than $4. She's going to spend at most $4 on the gift, and so on. That's all for now.